All right, so today we're talking about this lesson that deals with quadratic models in the real world. And we began in class talking about the first few problems. You should have found in class that the first answer was 100, number 1. You should have found the number 2 was about 1.5 seconds. You should have found number 3. You would see that inside the table, if you wanted to estimate the maximum height, you would look for where it stops rising, like it's rising here. And then it starts falling there. So you know it's somewhere between 1 and 2 seconds. You just estimate that to be around 100, maybe 104, but something near 100, considering that's so close to the top of its maximum height. So you look for where the graph stops rising and starts falling. And that's how you estimate its maximum height. And the next part of the table, it says when the rocket hit the surface, we decided that was 4 seconds. That point is called the X Intercept, or the point where the rock hits the surface, either way. How can you identify this on the table? On the table, you look for where the height, or the Y value, this is the Y column, this is the X column. Instead of X, they're using the letter T. Instead of Y, they're using H of T, or F of X, any of those. You're looking for where this column is 0, and that will give you the X Intercept. So the X Intercept will be 4, and that's when that Y value is 0. When the time is 0, it just tells you the height at the very beginning. So when the time is 0, there's a height at the very beginning of the problem. It said, what's the domain of this scenario? We decided that the domain was hard bracket 0 to 4 with the hard bracket. So the domain was from 0 to 4. We'll discuss why. It said identify the vertex. We should identify the vertex to have been 1.5 and 100. Because that would be the point where it reaches its maximum height. The next part says at 1 second, the graph is moving up, and at 2 seconds, the graph is moving down. And you should have also recognized in number 8 that in this equation, they gave you h of 0, they gave you v of 0. You would plug it in to be negative 16 t squared plus 48t plus 64. And that's where most of my classes stop. So you flip it over to the back. Most of you guys would have began here. All right, and it says, is the graph moving up or down? I think most of the side of the graph is moving down. And because A is negative, A is negative, and the other part would be with the vertex with max and min. You guys must realize that that would be a max because the graphs are going down. So it'll be a max. Number 10 says using the standard equation number 7, write it in vertex form. So now, some of my classes got that, so you can skip ahead of this, but most of my classes didn't. So number 7 equation was h of t was equal to negative 16t squared plus 48t plus 64. If you're going to write that equation in vertex form, you should recognize that you have to complete the square to do that. So what we would have done was group together the ones with variables. So group together these two and leave this 64 outside. From there you can factor out a negative 16. And that will leave you with t squared, take away 3t plus 64. And if you complete the square here, you will get negative 16. And t squared, take away 3t. Half of 3 is 1.5. So it's a decimal. That's okay. Squared. And you're going to put a plus 64. Then take away 1.5 squared. And that's going to be times negative 16. Because the a value was negative 16. So it has to be multiplied there. Final answer here would be negative 16. For the next step, it would be t squared, take away 3t, plus 2.25, plus this should be 100. You can do the math for it. So our vertex form would be negative 16, t, take away 1.5, squared, plus 100. So that would be the vertex form for that equation after you complete the square. So I can clearly see my vertex is what we said it was, 1.5, 100. So apparently number 8 relates to the equation in the picture above and on the front side. So the answer for that line, I think that would be number 10, which is that equation we just found. Number 11 says using the equation in number 9, what's the maximum height of the graph, and that would be the vertex. So that would be at 1.5, 100. This is your vertex. So if that's true, this is the height, would be the y value. So the max height would be 100. That's a y value, and that's the height. And x, and this would be time, and this would be height. Well, height. I'm not using h because we already have a word for h. H is axis of symmetry. So it's time and that's height. Number 12 says, use equation number 9. How many seconds did the rock change directions in the air? And again, that path would look like this. It would change direction in the air right here. And that would be the 1.5 value. So that would be at 1.5 seconds. Or after 1.5 seconds. That much time. And how we got this answer for it was we found the vertex. We found the t value of the vertex. T being time. Alright. It says that 1 second is a move up or down. We can find this out by plugging in 1 into our equation. And in the equation that we have, if we plug in 1, here's the equation. If you plug in 1, we can decide whether or not that graph is going up or down. But truthfully, I wouldn't do that. I would just look at the graph. I wouldn't plug in 1. I know that graph what the graph looks like. So I know from the front page. If this is 1.5 seconds, at 1 second, it would be here. And at 2 seconds, it would be there. So at 1 second, the graph is moving up. And at 2 seconds, the graph is moving down. So it's pretty easy to find out whether or not the graph is moving up or down if you have a shape of the graph. So whenever possible, if you can create a shape of the graph using what you understand about its vertex and the a value, I would. And I can kind of make predictions just with that much. And I think that'd be the best way of answering any question like this, having an idea what that graph looks like. All right, going on the bottom half of the page, we did not cover any of my classes. So let's talk about it now. In the bottom, it says a frog is about to hop from a bank on a creek. The path of jump can be modeled by the equation given there, where h is the height of the frog's jump above the water, and x is the number of seconds after the frog has jumped. And it says the fly is cruising at a height of 5 feet above the water. All right, so they gave us this great equation to represent the path of the frog's jump. We can think about this fly next. Let's first think about the path of this frog jump. The first question says, can the frog catch the fly without jumping? All right, and how do you know? So this represents the path of the frog's jump. Let's go ahead and find out what this graph is. I would find a value at 0 for x to figure out where this frog is at the very beginning of the problem. So if I plug in 0 for x, you plug in 0 there, this is going to give you h of 0, the height at 0, would be negative 0 squared plus 4 times 0 plus 1. So it's 1. So that's the ordered pair, 0, 1. So at 0, 1 represents the height of the frog at the very beginning of this problem. So there he is. Here's a fly, and it's just cruising by 5 feet above the water. It's my little fly. And this frog is going to do some kind of a jump. I don't really know the path of this frog's jump, but if I could find his vertex, I could begin finding that path. For example, if I use that equation and found his vertex, this is what it would be. So since the equation is h of x equals negative x squared plus 4x plus 1. And if you complete the square there, you get this. After grouping together the x's, you should get that line. After factoring out a -1, you should get this line. After finding the value of c, you should have found it was 4. So you have plus 4 here, subtract 4 there, times -1, because a was -1. So the equation for that frog's jump as a vertex form is -1 x track 2 squared plus 5. So this is the equation of the frog's jump. So let's keep that in mind and rewrite it. So before I ask that question, I'm just have this on the page. -1 x take away 2 squared plus 5 equals to the frog's height over time. So in the graph, I know that vertex is at 2, 5. So at 2, 5, that frog meets the height of his jump. I know the a value is -1, so we'll go to the left 1, I can go down 1, we'll go right 1, I can go down 1. And I really have enough points to draw the graph. The graph goes downward here, goes down through this point. This point reflects over the axis of symmetry. That's 2 over, this would be 2 over. So got another point on the graph, and I can figure out where it crosses the x-axis as well. But the question was, can a frog catch the fly without jumping? I don't think so. Unless that frog has a 5-foot tongue or 4-foot tongue. I don't know if frogs' tongues can go 4 feet away. So I would say no, cannot before it actually jumped, because I'm assuming a frog that's 2 inches long wouldn't have a tongue that can go 4 or 5 feet. Is it extreme value a max or min? A string value tells you max or min. So they could have left the word out string value and just say, is it a max or min? And this is a max because the graph goes downward because a value is negative. So that's a maximum. So what is the vertex of the equation? The vertex of that equation should be 2, 5. And the next part says, if the frog jumps to catch the fly with his mouth in one gulp, not by using a tongue, is it possible for the frog to catch a fly? So, assuming that the fly is jumping at the same rate the frog the fly is moving across the sky at the same rate the frog is jumping through the air, they could meet at the same place. So it is possible. Like, I don't know the speed the fly is moving at, but yes, it's possible. It's depending on several things though. It says graph the path of the frog and the fly. So this is the path of the fly, and this is the path of the frog, and it's probably going to cross somewhere in between 4 and 5 seconds when it actually meets the ground. All right, that's all I have, and now you should be able to try the second page I gave you, which was homework, if you think you're ready for it. Good luck.